Hello everyone, welcome to this new video. In this particular video, look into the DevOps features. So what we will do is we have a very small Python based application. We will learn how to deploy that particular application into the Amazon Elastic Kubernetes services, that is on a Amazon cluster, and then we will also see how to launch the infrastructure. In order to deploy this application, we will need the Amazon EKS and a few more, VPC and many other Amazon services. So we will see how do we launch the infra completely using the GitLab CI/CD. The entire thing will be done on GitLab CI/CD, starting from launching the infrastructure, and then converting our Python file into Docker image, and then deploying this entire thing into the clusters, and then finally we will also destroy and delete the resources that we have created. I will go one by one so that you can easily understand it for better references. Let me go to the agenda. So as I said, first I will show you the project overview, and then I will show you the GitLab pipeline design that I have set, and then we will go in deep dive into each and every job that we have created for the GitLab pipeline, and then I will show you the demo. And at the end, if in case you have any questions, comment the comment. So this is how the project overview is there. So we are completely doing everything starting from the building of our application till the infra launching and infra destroying everything using GitLab. We're not doing it on our local machine. Everything will be done completely on GitLab using its free runners that GitLab provides to us. So initially, what I will be doing is I will use AWS CLI commands, and then I will provision a backend of S3 and DynamoDB for storing the state files of Terraform. As you know, if you have gone through the Terraform, whenever you initiate a Terraform and then go with the planning, and then the applying of the Terraform files, Terraform will create a state file. So this particular state file, if you are doing it on a local computer, it will stay. But in case you want, if you have a very distributed infrastructure across the world or across many companies, then it's recommended that you upload your Terraform state file into a kind of storage. So in this case, we're using Amazon S3. However, GitLab also has its Terraform state repository. You can put it over there also. However, in my particular application, we will be using a DynamoDB table, and then I will be using S3, Amazon S3, and then we'll store our state file over there, and DynamoDB table will be to make sure that no any other person is accessing the state file at one particular point of time. Okay, then using Docker, what we will do is the Python the app script that we have, it's very small script for 5 lines of script. So this particular script we will convert into a Docker image, so that this image can be used again on our Kubernetes services, and then we will deploy our application. Let's go forward. So these are the jobs that we have in app. I will go to GitLab in a moment, and I'll show you all the jobs live. So the first job, what it will do is it will first launch a runner, and then it will install the AWS CLI commands, and using that it will then create a S3 bucket and a DynamoDB table for the backend. In the next job, Terraform plan, just to make sure that everything works fine. I will show you the Terraform files in a moment. So all the Terraform files, all the Terraform, what I'm doing is I'm mostly using the EKS modules that is provided through Terraform registry. You go to Terraform registry, Terraform is just search it, and you'll reach to the registry with the EKS module. You can come here and you can click on manage groups. Then it will automatically download whatever is needed. You just have to give a few names and then CIDR blocks. After the CIDR blocks and the names, it will automatically launch the required infrastructure backend at your AWS site. Okay, so I'll go back for project, and then the Terraform apply. So whatever we have planned, launch all our infrastructure into the AWS services. Then using Docker, we will build our applications image, and then that image we will pass it to our Kubernetes deploy, the EKS cluster that we will have launched. So we'll deploy it on the EKS cluster, and then we'll also create a service of load balancer, so that we'll be able to easily operate our we'll be able to easily reach our application to a URL. And then finally we will do all the cleanup using Terraform destroy, and we will also use the AWS CLI for deleting the S3 and DynamoDB table that we have. Okay, let's move forward. So okay, this is how the jobs are there. Let me go directly to the code so that I can show you. So this is the simple Python application that we have. It's a very simple application. As you can see, it says it will just display this particular message, and then if I go to Docker file, you can see I'm using Python 3.9, and then I'm switching into the working directory. That is, inside this I'm going, and then I'm copying all the contents of this, and then running this particular file. This has nothing but Flask, so we are using Flask here to run the application. So it will just go and it will host it on the 500. So it will just launch one URL, and then it will host that URL, and then it will show up this message. That's it. This is a very simple application. And using Docker, we will convert this into a Docker image, and then that Docker image we will use it in the Kubernetes cluster. Okay. So let's see what is this. Okay, so I was talking about this one, Terraform backend. You can see here we are defining the DynamoDB table that we will have in order to update our lock files. In order to update our lock IDs, that we don't change anything. Let me go to the pipeline directly and show you. It will be more easier. This is my AWS console. As you can see, if I go to EC2, we'll wait for a few seconds. As you can see, there is one default security group. There is no instances, and there is nothing here actually. But after we launch the infra, then you will see that our infra is launched, and clusters are created. Okay, so let me go to the GitLab pipeline first. Show you the pipeline. I'll go to build. I'll go to pipelines. Let me create a new pipeline so that it will be more easier for you guys to connect the new pipeline. New pipeline. This is how my pipeline looks like. I have 1, 2, 3, and then 4, 5, 6, 7, and 8. So I have 8 jobs with 7 stages because I'm doing the deploy. Okay. So if you go here, let me open my code. This is my pipeline code. Initially I'm using Docker image in the runner. So the runner will launch, it use Docker image for doing all our running pipelines. And for each and every runner, since I have 7 jobs, so 7 different runners will be launched at every time. It all already. And what I've done is I've made sure that manual intervention is there. So I don't want that after the after one job is done, moves to the next job automatically, and then so that the destroy job will also run automatically. I don't want that. I wanted this to be more kind of a little manual intervention, so that after one job is completed, I'll be able to manually trigger the next, and the next, and next, and then in that way we will be able to also what all the output, what is the output that we have. And it will take some time, but we will easily be able to troubleshoot in case something is wrong. Okay, so as you can see, these are the variables. So I'll be launching this into EUS West 1, and this is the registry where our the Docker file, once it's created, the image will be stored, and this registry is of GitLab. So let me show you that. If I go to deploy, I'll go to container registry. You will see here, this is my file, this is my image. This will get stored here after it gets built, and then that will be picked up by the Kubernetes. Okay, so what is next stage? The next stage is Terraform plan. So what I'm initially doing is I'm using a Alpine image, in which I'm doing all these things. If you see, are used for installing the Terraform on the runner. After that, I will do the Terraform plan, and that plan I'm saving into this text file. And then in apply, I'm using that proper I'm doing again, I'm installing all the required Terraform uh, installations and all, and then using that particular TF plan, that particular TF plan that we have stored. I'll be doing the Terraform apply here, as you can see. Next is we will be building the Docker image. So I'm just passing the registry information, which is these are all the variables. In case you want to know more about this, you have to go to the document tab. Using these variables, I'm passing the username and password and the registration and the registry URL and all. From where the Docker, it will know from where it has to, it has to log in and then update the what I say. What I mean is, it will know where to update the image of the Python code that we have. Okay. The next is the important thing, that is Kubernetes. So we're using kubectl, and then we are deploying our application. So this part is for installation, and then once it's installed, it will log in using the cluster name that we will have provided while we are creating the Terraform files. And then I'm doing two things. I'm doing a deploy.yml, through which I'm deploying the application itself, and then I'm also creating a service of load balancer for us to do it. And then at the end, using this job, what I'm doing is I'm just getting the information of our load balancer URL, and particular command. You see in center, I've got a lot of other things. Why? Because this is mostly put because the load balancer will take some time in order to generate. So I've put this for loop so that it can wait few minutes until we get the load balancer up. And then at the end, we will destroy everything. And then we will, okay, I forgot telling you guys about the first job. First job is this job. So in this particular job, what we are doing, we're creating let's say that you are doing a Terraform initialization, but want to do a Terraform initialization, you must make sure that the backend is already present. So I'm using AWS CLI commands to create a bucket on AWS, and then create a Dynamo table. And then once these both information is there, then I will be informing here the information of backend, and then the name of the S3 bucket we have. Using this, okay, then the Terraform will know, okay, I have to store this information over there. Okay. Okay. So yeah, so we have covered the entire pipeline. Let me go to Terraform files so that I can. This is for making sure that the Terraform, I mean, Dynamo table exists or not. If it exists, then we will have to inform it that lock key will be updated over here. So we will be using it as a backend. That is why the name of the file is backend. Next is EKS cluster. So this is a module that we have. As soon as the runner hits Terraform init, it will automatically download all the required behind, and it will store in the runner. So this is the EKS information that we will. It's a very little information that we're providing, but however, this will have a lot of behind the scenes services and applications that it start on the AWS infra side. So this is for S3 as I showed, and this is the output I'm expecting after it's right. So this particular thing is used for providing the access to our user. So we will be. I have already created a user. Let me show that fast. Go my AWS account and go to IAM. One second. I'll go to users. I have a user called Terraform user. So this user already has admin rights, but for some reason this admin rights are still not able to perform operations in the Terraform in the Kubernetes cluster, EKS cluster. That is why what I'm doing is I'm giving the access for that particular I'm giving the access for this user to the Kubernetes cluster, and then this is a binding service that is used for it to get a proper admin access. But unfortunately, this is also not working, so we will do that part manually. That's why I've commented this section. No problem. Next is security group. So go and see here. So it will launch security group, and then this is for ingress. This is for incoming traffic, and this is for outgoing traffic. So, and this is the CIDR CIDR block that we have given. So all our services will be launched in this particular IP ranges. Then we have variables that we are providing to it, then the versions that it will use, and then finally the VPCs, virtual private clouds, that it will launch. Okay, so I've showed you all the files. Okay, I've showed you deployment. So this is the ktest deployment .yml file. Using this file only, we will deploy our Python application. As you can see, it is pulling the image from this particular registry and then deploying it on the container port of 5000. Next is service. So using this, we are launching a load balancer service, and then this load balancer service will be this 500 whatever the information in the deployment the application is there. It will port into the 80 port, and our output will be able to see on the HTTP port, that is port number 80. Okay, so okay, I've showed you everything. Let us go to the application section, and then I will click on first this. So using this particular job, as I said before, we will be launching a S3 and an Amazon Dynamo DB table. So here, type S3. Only two S3 buckets should be there that I have already created long time before. Now three should be there or should be in the process of creating it. Yeah, so only two are there. But once this job gets completed, we will have three buckets, and then I will also show you Dynamo DB table. So we will have no DB tables created, but once that job is completed, we will have one Dynamo DB table as we have written tables. Okay, so it got created. Yeah, it got the job is successful. If I reload this, then we will also see a bucket over here, the name that we have specified in our yes, it's created. Very nice. Now I'll go to the next job. The next job, the planning will take place. Whatever the plan and whatever the Terraform files information we have given using Terraform plan, all that information will go into it. It is launching the Docker file because initially, as you can see here, we have in our pipeline we have informed to use Docker image only. This takes a lot of time. This will happen. Okay, so awesome. So the plan is successful. We have no issues from exactly these plans. Okay, so we have saved our plan into the TF plan. We've already done that. So I will go to Terraform fly now. This will take a lot of time. In case it takes a lot of time, I'll make sure I'll pause the video so that once it's created, we'll come back and see what all infra it has pulled up. So after this is done, and then we will build our tool simultaneously. Let me run this. I hope this is not dependent on this. Yes. So let me quickly verify. Fly and then build. So this is not dependent, and will anyway use a different runner. So we'll also run this simultaneously. The build process can also start. So our application will be built and then stored into the GitLab registry. It should be very fast, and the infra launching using Terraform will take a lot of time, at least 25 to 30 minutes. I feel, depending on the internet speed that you have. So that will take a lot of time. This should finish up in 2 minutes. As soon as this finish up, I will pause the video. But once that launches, I'll come back and I'll show you guys what all infra we have launched. Feel free to comment me if you have any questions. Also, after this particular video, I'm thinking I'll create a kind of AI chatbot or a kind of AI interface to which we'll be able to ask questions to it, and behind at the back end we will use ready-made AI services like ChatGPT service or OpenAI ChatGPT service or any other Cloudy or Cohere, and we will pull the data and we will create our own kind of AI ChatGPT stuff. So we will do that. After this, I'm thinking to do that. However, I want more. I hope you guys like this video after I upload it, and please subscribe to my channel, share it with your friends. Also, thank you so much. Okay, so this is done. As you can see, this all went nicely. Now, if I go to deploy, already there here, published 8 hours ago. Let me reload it. Hi everyone, back on. So I had paused the video. So you can see, our Terraform apply job has also run very successfully. And then you can see that the job is succeeded. It has returned us the cluster name that we created. So we did a lot of things here. Uh, the build job was also successful. So go here and refresh this page. You can see the image got created 10 minutes before. So this took the entire Terraform apply job took about 15 minutes. As you can see, our pipelines are going very good. Terraform apply also ran well. Next is, if let's go and check now in the AWS console. To go to EKS. Yes, our cluster is created. I'll go inside this. I said you that something we will have to do it manually. That we will do it. So if I go to access, we go down, go here. You can see that our user is created called Terraform user, but unfortunately it will not have any policies. You can see policies are completely empty. So I'll go here and I will add the policy to it. The policy that we need is admin policy for EKS cluster. So Amazon EKS cluster admin policy, and then and click on add policy. So it got created. Now we'll have all the necessary things that we have. Next is running the next pipeline. The next pipeline is deploy pipeline. Let me run it. I'll click on deploy here. So done, very nice. You can see it got created. The service also is created. If I go here and see now, you will see the load balancer will be created. Load balancer would have been created, and yeah, instances that we have launched. If I go back to the code and I'll show you guys. Return here. How many instances we are expecting? So we're expecting nodes. A desired node is 2, minimum is also 2, and maximum the size is about 6. So that is why we have two instances here that are running. It has automatically created one elastic IP, so that give any static address. There were 4 security groups, now there are 7, and there are 2 volumes attached to each of the instances, and there is one load balancer created because of the deploy run that we did. And I'll go back and I'll get the information of. I can directly go and get the load balancer address from the console also, but I want to run this so that we have our address over here, and then we'll be able to see our application live working. So let's see how that went. Okay, so as we can see, our the service job also has run. We have the information with respect to our AWS load balancer IP. Let me copy it and then paste it here. See, our application should be online. Yes, as you can see, it says hello Kubernetes manifesto. Means our image got successfully built. Yes, uh, as we can see, it's working, and our job got built and our application is online, and all the jobs went very nicely. The next jobs are the destroy job. First we will destroy all the cluster and all the resources related to it, and at the end we will also destroy the S3 and DynamoDB. So you can either get the load balance IP from there, or you can directly go here in to dashboard and get the load balance IP. I mean the DNS name. You'll see here balance it, go down, DNS name, go and put it, empty browser, use your application. However, this has been a good video so far. So please subscribe to the channel, share my video. Thank you so much.